Right. Let's look at the lines and the equation. So we have different lines here, and then we need to check the equations. So each line in an equation here. So now where do we start? Because they're straight lines, so we are used to have the equation of straight line. The standard one is y equals to mx plus c, where this is the y-intercept, and then of course this is the gradient. Then our gradient is defined by y2 minus y1 over x2 minus x1. So gradient in order changing in slope, or the changing in gradient, because the gradient, or the changing in line, the rate at which the line will change. So the value as it goes, it is increasing or decreasing. Right. Now let's start by having this line. Let's have this line here. Now on this line, let's identify the coordinates first. So I selected this coordinates here. What we have, so coordinates to omega x, so root over 5 and 2. So 5x, then correspond directly to 2 for 1. Then it's fine. Another coordinate is here. What we have, so the x at this line is 0, and then the y, the x at this point is 5, because he's here 5, and then the y is 0. So this is the line of x-axis. So can you see that at x-axis the y is 0? That case is fine. Then there is another point here where x is 5 and the y is minus 4. The y becomes minus 4. It's here. They correspond to this one. Alright. Now having a line like this, of course, if you try to find the gradient of this line, let's try and try to find the gradient here. So the gradient of the line, this one. So we can pick any two coordinates. So let's pick this point and this point. So having our equation like this, so we'll have y2. So if y2, we say is 2, and then of course it means the y1 must be here, minus 0, over x2, 5, and x1 minus 5. So looking at that, it means we have 2 divided by 0. So 2 divided by 0 is undefined. So meaning there is no gradient. There is no gradient for this line. So if there is, the gradient does not exist. So but or linear okay, linear ikata, so ikata the value of x. So meaning the equation of this line will be x equals to, then ikata will be x equals to 5. So it means the equation of this line will be x equals to 5, since there is no gradient at all, but ilo kata at the x-axis. So it means the equation of the line will take the line of x only. Then of course, let's look at this one. There's another one here. So this line is saving the x here is 0. So it means the other coordinates here is 0 and minus 2. The other coordinates here 0 and minus 5. So can you see that at the y-axis, the x is 0 throughout, even if you pick out this point here, 0 and 1. So x is 0 throughout this line. So the x is not changing. So the line it's only changing but at y, but it's going to cut only x. So meaning that the equation of this line will only be x equals to 0 at y-axis. So that's why I say at y-axis the x is 0. So that is the equation of the line here. Now again, this line is parallel to this one. So if they are parallel, then that's why they have both they don't have gradient, then their value is that way, the equation. Now even the equation of this line, so we don't need to do the gradient, not that there is no gradient, then the value here, the equation of this line will simply be x equals to then minus 3, and that is the equation of that line. Right, then this line is also parallel to this one, and also parallel. So any line that is parallel to the y-axis, because this line here is for y-axis. So any line parallel to y-axis, it means you have the equation of x equals to. Now we can say the general equation for the line that is parallel to the y-axis will say x equals to a certain value. You can say k, where k is just a number. Right, now let's go to this line. Now this line is moving horizontal. Now if it's moving horizontal, or let's start here. This line here is saving the coordinates here, minus 3 and 0. And then another one here to identify like a 5 and 0. So the value of x is changing, but the value of y remains the same. So meaning that if you want the gradient on top, the y values will be 0 minus 0 over 5 minus into minus 3. So but 0 divided by any number here, which is 8 in this case, so will be 0. So the gradient here will be 0. So if you multiply here by 0, then we're only left with c. So meaning that the equation of the line that is parallel, or that is in horizontal, then it means the equation of this line here is y equals to 0 in that case. So that's why I said on the x-axis, the equation of the line is y equals to 0. Now if you check this one, this line, the coordinates here is minus 3 and 4. This one here is what we have, 7 and 4. So the value of y is not changing. Therefore, it means the equation of this line the line is going to cut the y only. Then we have y equals to 4 for this equation. So this one quickly, because it means this line is now parallel to this one. So this one will never change. The values then will be y equals to minus 3. So the equation of the line in that case, over parallel to the x-axis, then it will be y equals to. So now it means there is no the gradient is 0. Now let's have this one. So there is blue one here. Now can you see that if you find the coordinates here is 0 and 0, but here is 1 and 1. So if you try to find the gradient here, so the gradient of that this line, of course, will be the y will be 1 minus the y here, 0, 1 minus 0. So the gradient here will be 1. So if the gradient is 1, then we have y equals to 1 multiplied by x plus c. So which is y equals to x plus c. So the equation of this line, it means will be if we have c, so you substitute 0 and 0, which is one of the coordinates, or 1 and 1. So we have 0, 0 equals to plus c. So it means c is 0. So it means the equation of this line is y equals to x. Now the equation of this line y equals to x, because we get the same point. Even for this one, now because it's sloping to the negative, the gradient here, if you get it, will be negative. Then it means the equation of this line equals to minus x. Then that will be the equation of this line. So you must master these lines.